What is this? Any idea? Any idea? No idea. Shazan, what
Like
is this?
heating something up? Is it heating a
Yes.
solid up?
Yes, heating is solid. Ice. This is ice.
Yes, ma'am. It's melting.
Hmm?
The melting process.
Yes, melting. And this is container 558. 2 more minutes to go. Total, how many? There are 3 states of matter, right?
Ma'am, 4.
4? Okay.
Ma'am,
Name.
plasma is also, right?
Yes, plasma is also there. 3 states of matter we already know, which is solid, liquid, and gas. And the 2 more states of matter is also possible. First is plasma, and second one is, any idea?
No, ma'am, I have not heard of it.
No?
Ma'am,
Bose.
Bose-Einstein condensate.
Yes, yes, very Bose-Einstein condensate. So let's start now. Okay, what is plasma? See, here this is my container. Let's take ice in one container and let's heat it. Okay, where's Arham? Arham left. Okay, Shazan, see. Let's take ice in one container and let's heat it. What will happen?
Sorry, ma'am, the page reloaded.
Okay. Arham, what will happen if we will heat this ice?
After some time, it will turn into water.
Ma'am, it will turn into liquid.
Yes.
Like, ma'am, the molecules actually break. The bond of the molecules actually
Hello,
break.
ma'am.
Hello, Advika.
Due to increase in temperature.
This is the last topic, Advika, the plasma, okay, of this first chapter.
Yes, ma'am.
Yes, so Advika, do you know what's the 2 more other states possible?
Ma'am, plasma and something from B, ma'am. Forgot its name.
Yeah, this one. Okay.
Yes, ma'am.
Condensate. PEC, you can say. Okay. So let's take Advika. Here we are taking ice in one container and we are heating it. So what will happen? Ice will convert into water, right?
Ma'am, water. Ma'am, because it's being heated.
Solid to liquid state. Then now if we will heat more, heat this water more and more, then what will happen? It will start boiling. Right?
Yes, ma'am.
Yes. If we will give more heat, then what will happen, Adham? Starts boiling.
Ma'am, start boiling.
Yes. Shazan, correct or not?
Yes, ma'am.
Now what will happen? Now giving more heat, like up to 6,000 or 7,000 degrees Celsius. So what will happen? Then the atoms which is present inside this, means inside this container, it will become ionized and it will emit electron, and it itself convert into cation, means positive. See, giving more heat up to 6,000 or 7,000, then what will happen? Atom inside this will become what? What, Arham? Ionized?
Yes, ma'am.
Ionized means?
Ma'am, it become plasma, right?
Yes, it will become plasma. So what is ionized? Ionized means it will emit electron and it itself convert into cation. Cation means positive. And it itself convert into cation. What is cation? Positive. Arham, am I correct?
Yes, ma'am.
So as we already know that electron is negatively charged. Electron is negatively charged, no? Yes or no?
Yes, ma'am.
So what will left in the beaker? Only the negative charge, negative, positive, negative, and positive. Mixture of both negative and positive. Mixture of both negative and positive. See, this gas become ionized and this whole process is known as plasma. Ionization is, so in simple way we can say that ionized gas called plasma. Let me write it down. This gas become ionized, and what's this process called? This ionization process is called plasma. So here what happened? Normal we are heating solid to liquid, so it will turn it to liquid, and if we will give more heat, it will start boiling. Now if we will give more heat up to 6,000 or 7,000 degrees Celsius, So what will happen? Atoms become ionized. And what is ionized? Ionized means emit electron and itself convert into cation. So in this beaker is left with only the negative and the positive, negative and the positive. So this beaker will be the mixture of both negative and positive ions. So negative mixture of both negative and positive means ionization, है ना? So this gas becomes ionized, and this ionized is called plasma. This whole process is called plasma. Any doubt?
No, ma'am.
No? Shazan and Advika?
No, ma'am, I don't have a doubt.
No? Okay. Shazan? It's
No,
easy?
ma'am.
It's easy or tough?
Ma'am, it's very easy.
It's very easy, yes. It's very easy. Just simple logic. Now, if we increase heat, it becomes ionized. Why? Any idea? Any idea? If we increase what? Heat.
Heat.
So it's becoming ionized, right? It becomes
Yeah.
ionized. But why? Why? Any
Ma'am, I don't know.
no idea, na?
No.
No? Anyone? Nobody?
Ma'am, actually it gets charged and it gets ionized. This is the reason, ma'am.
Yeah,
It
somewhat. Correct. So see what happened here. This is my nucleus, है ना? And this is electron. See, like this is my nucleus. Okay, wait. Let me draw with red color. This is my nucleus, the positive, and this is electron, the negative. Electron revolves around nucleus, है ना?
Okay,
Yes,
ma'am.
ma'am.
Yes, electron is revolving around nucleus. So what will happen now when this electron will gain energy? Then what will happen? When it captures the energy, it moves to higher orbit. Now electron will be here. है ना? Now if more energy, then again it will shift to next orbit. Let's say this one. If my electron is getting energy more and more, then it is shifting to the next orbit, the higher orbits. Okay?
Okay, ma'am.
है ना? So but when this is what? This is electron. But when electron will get sufficient amount of energy, then what will happen? Electron will leave this atom and it will move outside. See, when it will get sufficient energy, then what will happen? Electron leaves this atom and move outside. Firstly, what's happening, that my electron is giving some amount of energy, है ना? So it's shifting to higher orbit. Again, more energy. Again, it's shifting to higher orbit. So what happen if electron will get sufficient amount of energy? Then it will leave this atom. It will say, okay, this thing is getting me like more and more energy. So electron will leave this atom and it will move outside. So electron will be here, outside in the surrounding. It will not be there in that atom. Okay? Now, see, it came outside from the influence of nucleus and it become free electron. If my electron will come outside from what? From the influence of nucleus, then what will happen, Arham? It becomes what?
It becomes ionized.
It becomes free electron. It becomes free electron. So inside beaker or container, if we will give very much amount of heat, then what will happen? The electron will capture that heat, means the thermal energy. So what will happen? The electron will capture that thermal energy and came outside from that influence of that beaker or from that influence of that nucleus. Right or not?
Yes, ma'am.
Any doubt? Arham, can you explain me this part again? That what's happening here?
Ma'am, what part?
This part, this atom part, this electron part, where electron is moving outside.
Ma'am, when you add heat to a gas, what happens is
Gas. When we will give heat to electron, then what will happen?
It will get ionized.
And it will move to higher orbit.
It moves to higher orbit.
And if we'll give sufficient amount of energy, then it will leave
It will leave the whole it will leave the nucleus.
The whole atom. The whole atom it will. Okay?
Yes, ma'am.
Advika and Shazan, can you guys explain me this part?
Ma'am, like, can I just explain once again?
Okay. See what's happening. Here is nucleus and Advika, What about you? You got it or not?
Hello.
You got it?
Yes, ma'am. Yes, ma'am. I got it. Sorry, I
Can,
was not able to unmute.
okay, it's okay. Can you please explain this part?
Yes, ma'am.
Yeah. Go ahead.
Ma'am, the nucleus one, right?
Yeah, this part. This one. That why electron is moving outside from the atom.
Yes, ma'am. Oh, ma'am, ma'am? You mean why the electron is moving outside the
Yes.
why it's moving outside the like, and why it's not inside the like nucleus with the protons and neutrons, right?
Hmm.
Yes, ma'am. Ma'am, it's moving outside because it has a negative charge to it, and ma'am, like when there is ma'am, like and ma'am, because of the sufficient energy, like ma'am, when because of the extra energy, they move outside the electron, and since the and ma'am, their weight is also like way less in comparison to that of the nucleus and the protons. That's why the nucleus and why the nucleus and protons stick together and the electrons move outside.
Hmm. And if my electron like move away from the influence of nucleus, it will become a free electron, right?
It'll become a free electron, ma'am, and this usually happens when like we're like combining two atoms, then the
Hmm.
change of electrons and protons happens.
Yes, very
Just the change of electrons.
yeah. Yeah. Shazan, any more doubt? Okay,
No, no.
let me explain once. See, this here is my nucleus, and this is the electron. If my electron is getting more and more energy, then it will shift to the next orbit, the higher orbit, and again, if it will get more energy, then again it will shift to the next orbit. Means the higher orbits, total 8 orbits, right? Then it will again shift. Then what will happen? If electron will get sufficient amount of energy, then it will leave the atom at it, and it will move outside, and it will become a free electron.
Okay, ma'am.
Okay, doubt? No. So see here, what's happening? Like inside my beaker, this is my beaker. Let's say, very much. If it will give heat, means thermal energy, then what will happen? The electrons will what? The electrons will came out from this influence of this nucleus, or from that, or from this container, and it will become a free electron. So now the atom which is losing electron, that will become negative, positively charged, and electron is negatively charged. We already know this, right? That electron is negatively charged, and the atom which is losing the electron, that will become a positively charged electron. Wait, electron that elect sorry electron electron which is losing, the atom which is losing electron, that will become positively charged, and my electron will and my electron is negatively charged. And so now what will happen? So now where plasma will get naturally, do you know what's the natural thing where we get plasma? No? Any doubt in this like whole thing, the electron going, coming? Any doubt here or anywhere?
Good evening, ma'am.
Yes.
Ma'am, I'm new student. My name is Ravi Sajid, and this is my first chemistry class here.
Yeah. So
Ma'am,
huh.
I joined like 4 minutes late. Can you explain it to me once again?
Yeah, sure. So here what's happening, let's say I'm taking one beaker, one container, okay, and here ice is there, and we are heating this container. So what will happen if we will heat a ice? Normally what will happen? The solid will turn it to liquid, right? So if we will give more heat, let's say, then what will happen? It will start boiling, है ना? And let's say we are giving more and more heat, up to 6,000 or 7,000 degree Celsius. So what will happen? Atoms will become ionized. Ionized means it will emit electron and itself convert into cation, which is positive, and electron is negatively charged. If we will give more and more heat up to this much, the atom will become ionized. Ionized means it will emit electron and it will itself convert it into cation, means positive. So see, what's happening here is this much you got now. So what will happen? See, this is my beaker. So if my atom becomes ionized, means it will emit electron, the negative charge, है ना? Okay, wait, maybe just a second now. What's happening? Just a minute, please. I'm sorry. So, okay, let me just, okay. So what will happen? If we will heat it up to 600 to 700, atom will become ionized, means it will emit negative thing. So in this beaker, here is negative part and also the positive part, right? है ना? So this beaker will be the mixture of both the ions, the negative ions and the positive ions. So the mixture of both the ions, it means this gas become ionized, and this whole process, the ionization process, is known as plasma. Plasma, in simple way, you can say that, we can say that the ionized gas is called plasma. And what is ionized? The mixture of the positive and the negative ions. Correct? Any doubt? Any doubt? What's your name? Sajid, right?
No, ma'am, Razi.
Okay, Razi. No doubt, right? Razi.
Yes.
So here, see, here, what's happening? This is my nucleus, and electron is revolving around the nucleus. है ना, Razi? So what will happen? If I will give more energy to my electron, it will move it to the higher orbit. And if I will give more, then it will again move it to higher orbit. So let's say if we are giving the sufficient amount of energy to my electron, so what will happen? The electron will leave this atom and it will move outside. Moving outside means my electron becomes the free electron, है ना? And it will move outside. Okay? Till this much, any doubt?
No, ma'am.
No doubt. Okay.
No, ma'am.
Now where plasma we get naturally? Any idea? See, in stars we get plasma naturally. This is my star, let's say. Okay, this is star. In cloud we get plasma naturally. Now let me explain. Here in star, temperature is very high, है ना? Temperature is very high. Temperature very high. So what will happen? Sufficient energy is available to make electron out from the nucleus. If temperature is very high, then what? See, this thing, can you guys relate? If temperature is very high, means the energy is very much, then what will happen? Electron will leave the atom, means electron will leave that star and move outside. See, if temperature is very high, then means sufficient energy is there inside this star. So this will make available to this. So this sufficient energy is available to make my electron outside from the nucleus. Any getting it? Okay, let me write. In star, what's here? Sufficient energy. Sufficient energy is available to make what? To make electron out from nucleus. है ना?
Yes, sir.
Energy is more, then obviously my electron will move out from the nucleus and it will become a free electron, like here. So here also the same thing will happen. Shazan, Advika, and Razi, any doubt? If temperature is high, then obviously it's making my electron to move out from the nucleus, है ना? So now what will happen? See, this universe, this whole universe is made up of mostly of stars, correct? And inside star, the matter is in plasma state. So we can say that this universe is mostly made up of plasma. Let me write. See, universe.
It's mostly made of
It's
plasma.
like a surface of the sun is also made up of plasma.
Yes.
All of the stars are made of plasma.
Universe is made up of what? Mostly of stars. Stars. Okay. Inside star matter, there is a matter of what? Plasma. Because here we already, है ना?
Yes, sir.
Inside star, matter of what? Plasma. So we can say that 99.9% my universe is made up of plasma. Am I correct or wrong?
Yes, sir, you're correct.
Correct. Okay. Razi,
Yes, ma'am.
any doubt here?
No, ma'am.
So, ma'am,
No, ma'am.
Universe mostly made up of what?
Plasma.
Plasma. Because this is star. If this is getting more energy, then it will make my electron move out from the nucleus. And here, if my electron will move out, then what will happen? This gas is becoming ionized, है ना? So
Yes,
universe is made up of stars. Star is inside star. There is a matter of plasma. So we can say that my universe is made up of plasma. Correct? Advika?
Yes,
Yes, ma'am.
ma'am. I understood. Yes, ma'am. Ma'am, can you explain it again? I'm a little confused.
Confused where? Here. See, this is my star. है ना? Inside star, temperature is very high.
Yes, ma'am.
So sufficient energy is available inside my star. So sufficient energy is there, then what will happen? It will make available my electron to move out from nucleus. Like here, if sufficient energy we are giving, then what's happening? My electron is moving out from the atom and it's becoming a free electron. है ना?
Yes, ma'am.
So we can say that na, ki universe is made up of stars, like all the solar system, all the planets, and inside this star there is a matter of what? Plasma.
Yes, ma'am.
Plasma, because sufficient energy in that thing. So we can like say that ki 99.9% my universe is made up of plasma, because my each star, the inside star, there's a state of matter. So that's how we can say that the universe is mostly made up of plasma. Any more doubt?
No, ma'am.
No? Understood?
Yes, ma'am.
Okay. Now, next, what is naturally in cloud also plasma is present. Can you like explain it how? That
Ma'am, I don't know.
What?
Ma'am, I don't know.
Okay, I don't know. Okay, let me explain. See, inside this cloud, this is my cloud. What will happen? The exchange of charge takes place when cloud passes from each other. See, let's say this cloud is my positively charged. Okay, this cloud is my positively charged, and here is one nucleus. This is like this. This is my nucleus, the positive one. This is what? Positive. This is my nucleus, and this is what, Anam?
Ma'am, electron.
So see, let me explain. See what will happen. This cloud will put which type of influence in atom, which is okay. See, you know that, right? We know that unlike charges attract or repel.
Ma'am, like charges, the same charges repel.
And the unlike one attract.
Yes. Yes, ma'am.
Unlike charges means positive and negative charge. Will what? Will attract or repel? Anybody? Razi?
Yes, ma'am.
The positive and the negative charge will attract or repel each other.
I think they will attract each other.
Yes, attract each other, and the same charge will repel. है ना? The positive and the negative attract, and the positive will repel each other. So what will happen? See, in this cloud, there is a huge amount of positive charge. है ना? And this positive charge will attract electron towards itself, because this is my positive and this is my negative. Positive, negative will attract each other. So this positive thing will attract my
Negative.
electron towards itself, right?
Yes, ma'am.
Yes. So because why? Because electron is negatively and my cloud is positively charged. So what will happen? And this positive charge will move away from nucleus, and it will repel. So in this way, what will happen? The positive and negative will split. It will split. Why? Because this positive will attract this negative thing, and the nucleus will split. So it will be like this. The negative will be here and the positive one will be split, and this negative will go to the positive cloud area part. है ना? So see what will happen. This cloud is making ionized gas. So how this cloud is making ionized gas? Anybody? Why? It's very simple.
Ma'am, because the cloud is positively charged and the atom and the electron is negatively charged, so it will attract and then it will separate. So
Very good. See, like here also, in this beaker is a mixture of positive and negative. That's where this gas become ionized. So here also same thing is happening. My cloud is positive charge and it's attracting the electron, the negative thing. So we can say that, right? This cloud is making ionized gas in the surrounding. Right or wrong?
yes, ma'am. It's right.
Shazan, Advika, Razi?
Yes, ma'am.
है ना? कोई doubt? Any doubt? Advika? No? Okay. So we can say that this cloud is making ionized gas, and here becomes the channel. This type of channel, it will be there. So this channel, and here becomes the channel of plasma. Through electricity will be conducted. Yes, I can hear you. So this this will become a channel, and this will become a channel of plasma because my positive and negative charge is combining and it's forming a ionized gas. So in the surrounding of the cloud, it will become one channel, the channel of plasma, through which the electricity will be conducted. Through which what will happen? Through which the electricity will be conducted. The positive and negative thing will be there. Then what will happen? Obviously, the electricity will conduct, right? So plasma is a mixture of positive and negative ions. We can say that the plasma is a mixture of what? The positive and negative ions. If more charges are present, then it can easily conduct the electrical current because of the positive and the negative charge are combining here, and it's forming a channel of plasma through which the electricity is conducting. And if more charges are present, then it will conduct a electrical current. Now let's see. Now this positive charge flow from this channel, and see, the positive charge will flow from this channel, and this is known as lightning. Lightning happens, right, in the cloud. Why lightning happen? Because the positive charge flow from this channel of plasma uh, around the like the surrounding of the cloud here. That's why the lightning is happening, and lightning is also a form of plasma. Lightning is also a let me write here. Lightning is also a form of plasma, and lightning is known as partially ionized plasma.
Ma'am, actually, I've also heard in TVs there's also plasma, right?
What?
Plasma TV, something like that. I've heard about that.
TV, plasma TV. That one?
Yeah.
Yeah, plasma TV is also there. So see, here is TV now. this TV is plasma TV. Okay. So the lightning is a form of plasma, and lightning is known as the partially ionized plasma, and inside sun or star plasma is called the fully ionized plasma. See, the lightning is called partially ionized plasma.
Yes, ma'am.
And inside my sun or any star, there is a fully ionized plasma. Means here is what? Here is my fully ionized plasma. Fully ionized plasma. Now we will learn about the fully and the partially ionized plasma. But let me just see. Here, any doubt? The negative charge is the cloud is having the positive charge. Here it will attract my negative thing because positive and negative will attract each other, and the negative or positive will repel each other. So if this positive thing will attract my electron, this electron and nucleus will get split. Here it will get split, and if negative and positive will be there, then it will become a ionized gas, है ना? Because negative and positive is there, just like my beaker. Here is also the mixture of negative and positive. So this is also becoming an ionized gas. And this ionized gas is called plasma. Plasma means the combination or the mixture, sorry, not the combination, the mixture of both the positive and the negative charges. So if this will combine, the positive and the negative charge will combine, then it will form a channel of plasma. Channel of plasma, matlab ki channel of plasma means the mixture of the positive and the negative ions, है ना? And through this channel of plasma, what will happen? Electricity will be conducted. Okay.
Okay.
And if more charges will be there, then what will happen? It can easily conduct electrical current. So this is also the phenomena. This phenomena is also known as the lightning, because here is the mixture of both the positive and the negative charges. Lightning happens na through cloud, like this, है ना? So this is also a phenomena of plasma. This is also known as plasma. Lightning is also known as plasma. Any doubt?
No, ma'am.
Anybody? Any doubt? Razi, Shazan?
No, ma'am.
No, ma'am.
No? Everything clear?
Yes, ma'am.
है ना? Razi? No doubt?
Yes, ma'am.
No doubt? Any
No,
doubt?
ma'am. No, ma'am. No, ma'am.
Okay. So let's talk about partially, and what is partially and My lightning is known as partially ionized plasma, the partial one, and inside my star or inside any my solar system, that's fully ionized plasma is there. Okay. Now let's talk about the partially ionized and fully ionized plasma. What is this? So here, let's say this is my beaker. Here negative, no, here is what? Here positive, 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 this, negative, 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 negative. Okay, this is what? What is this? These are the neutral atoms. है ना?
Yes, ma'am. Yes, ma'am.
These are the neutral atoms. Neutral atom means ionization won't take place here right now. It's not positive also, it's not negative also, it's neutral. Okay.
Yes, ma'am.
And these positive thing is what? These are ionized. Ionized. So why positive ions and negative charges is not equal here? Let's talk about this. Okay, change the color. So okay, it may happen one atom produces or donates more than one electron. See, why positive? See, positive is how much? 1, 2, 3, and 4. You know, 4 positive charges, and negative charges is 1, 2, 3, 4, and 5. 5 negative charges. So why the positive and negative charges are not equal? Why? Because it may happen that one electron produces or donates more than one electron. So here the number of electron is more than the positive electron. है ना? It may happen na कि one atom produces or donates more than one electron. That's why the number of negative electron is more here than the positive. Okay, see, now let us learn some terms. What is we will learn plasma density, degree of ionization. Okay, just a second. What is plasma density? Anybody, any idea what is plasma? Shazan, what is plasma density?
Ma'am, plasma density.
Yes, what is plasma density?
Ma'am, it is the concentration of gas particles in the given volume of ionized gas.
Plasma density is number of free electrons per unit. Okay. Number of free electron per unit volume. It means, see, 1 cubic meter. Let's say this is my 1 cubic meter. Okay, 1 cubic meter container. Okay. Now, what will happen in 1 cubic meter container? There are 5 free electrons. 5 free electrons means this one. 1, 2, 3, 4, and 5. 1, 2, 3, and 5. Okay. Let's say here is 5 free electrons. So what will happen? So we will represent this like 5 free electron per meter. This is the plasma density of this container. This is the plasma density of this container. Because plasma density is what? Number of free electrons per unit volume. And here is how much number of free electrons? 5 free electrons. 1, 2, 3, 4, and 5.
Yes, ma'am.
So we can say that the plasma density of this container is 5 free electrons per meter cube. We can say it? Okay? Yes. Now let's learn about the degree of ionization. This is one term, and the second term is degree of ionization. Razi, if in this container, let's say one more negative thing is there, then what will be the plasma density?
Ma'am, 6 free electron per meter cube.
Yes, very good. 6 free electrons per meter cube. है ना Aram? Aram getting it?
Yes, ma'am.
What is everybody? Where's Shazan and Advika? Okay. What is degree of ionization? Total 9 atoms was there, and only 3 get ionized. Okay, let me explain. See here. What is the? Just a minute. Here, what is the degree of ionization? Degree of ionization means number of cation upon number of atoms plus number of cations. Number of atoms plus number of cations. And here, number of cation is how much? Anybody? Number of cation is how much? Tell me. Total how many atoms? Total 9 atoms are there. See, 1, 2, 3. This one is 4, 5, 6, 7, 8, and this thing is 9. Total 9 atoms. These are the neutral ones, so we'll not count it. Total 9 atoms are there, and total 9 atoms was there, and only 3 gets ionized. Ionized means what? What? The positive and negative, the mixture of positive and negative, right?
Yes, ma'am.
And only, let's say, only 3 gets ionized here. So what will happen? The number of cation is what? 3 upon number of atoms is how much? 9. Number of atoms plus number of cation. So it will be 1/3 part. So 1/3 is the degree of ionization of this beaker. Okay. Only number of atoms. Okay. Degree of ionization means number of cation. Number of cation is 3. Cation means the neutral parts. The neutral parts means the ionization part, and here the total number of atoms is 9. So it means 1/3 is the degree of ionization of this beaker. So 2 terms is here. One is plasma density and another one is degree of ionization. Okay. So let me write one formula. One formula will be there is Ni upon Ni plus Nn. What is Ni? Ni is the number of ions, and Nn is the number of neutral atoms. Nn is the number of neutral atoms. So this is the total number of atoms before ionization. Before ionization, this is the total number. It means total 9. See here also, number of atoms plus number of cations before ionization means here total is 9. And number of cation is 3, the thing which is not get ionized. And this is the formula. Ni upon Ni plus Nn. Ni means number of ions and Nn means number of neutral atoms. And this thing is what? The total number of atoms before ionization. Total number of atoms before ionization. This is the simple formula.
Okay.
Now, electron ion collision frequency is what? In every unit time, how many electrons? See, now let's talk about the fully and the partially one. Okay, the first thing is, let's talk about, okay, let us know about some terms. What is this? What is this? Okay, see here, electron ion collision frequency. Any idea, Razi, what is electron ion collision frequency? No?
I don't know.
In every unit time, how many electrons and ion collision is happening? That is electron ion collision frequency. In every unit time, how many electrons and ions collision is happening? In every unit time, how many what are them?
And collisions are happening.
How many electrons and ion collision is happening? That's known as electron ion collision frequency. Collision is happening. And we will denote this thing like this. E for electron, I for ion. Okay. Now, one more term is here, that what is electron neutral collision frequency? Can you please tell me the formula or this denoting part of electron and neutral collision frequency? It's same as electron ion. Arham, Razi, it should be what? E and what? Come on, fast. E and what? Here E and I, because electron and ion collision is happening. Here what? E and yes, N, because electron and neutral collision frequency is happening. And Arham.
Yes, ma'am.
Now, these two will decide which is fully ionized and which is partially ionized. This two will decide whether there's a fully ionization is happening or partially ionization is happening. How come? Let's see. This is my this is my fully ionized. I'm writing only ION. Okay, and this is my partially ionized. See, if my electron ion frequency is more than electron neutral frequency, then it will be fully ionized. Okay. And
Okay.
partially will be what? If my electron ion frequency is less than electron neutral frequency, then it will be partially ionized.
Okay,
So
ma'am.
here in lightning is partially ionized. It means what? It means what? The electron ion frequency is more or less than electron neutral frequency.
Not less than electron neutral.
Yeah, go ahead. Electron neutral is less or this or this. Adham.
Ma'am, electron ion frequency is greater than electron neutral frequency.
No, that's fully. This is partially. So here partially this electron ion will be less than electron neutral. Okay. In lightning, partially ionized, partially means the N will be greater. Means partially you can like learn it how the partially north means north side partially. Okay. Let it be the okay. So here in my star, the fully ionized means electron ion is greater, right? Then electron neutral. Okay. Arham,
Yes, ma'am.
got it now?
Yes, ma'am. Got it.
And this, what about this? This is very, very like a rare condition. This is rare. Okay. So till now we have talked about this, the two terms. Plasma density means number of free electron per unit volume and the degree of ionization. And this formula is very important because this Ni is referring the number of ions. Ni plus Nn is the neutral thing. Means this whole thing is the total number of atom before ionization. And here this 2 symbol is denoting that which is fully ionized and which is partially ionized. This is the denoting thing of the fully is means electron ion is greater than electron neutral and partially is electron neutral is greater than electron ion. Okay?
Okay, ma'am.
Okay, any doubt? Anybody?
No, ma'am.
No, ma'am.
Okay. So what are the let's talk about okay, it's 50 now, 10 more minutes. Let's talk about the applications of plasma. Any idea what is the application of plasma, Arham? That plasma TV is the application of plasma. Okay?
Yes, ma'am.
I know.
I'm also for those lights.
Yes, very good. Very good.
I think they're called like neon lights or something like that.
Huh?
No, I don't remember what they're called. I think they're called like neon lights or
Fluorescent
something.
light?
What?
Fluorescent lights.
Oh,
Applications of plasma. This is the application. See, this is this thing is like normally outside the shop, na? The lightning thing. I know.
I've seen those.
Yeah, this is what the fluorescent lights means. Nowadays, fluorescent lights are substituted by LED lights because LED lights is more costly. Okay, okay, and this is a plasma TV. This is
Like less cost, right?
Here, what's happening now? Let's say this is one rod, okay, and one tube, let's say, and inside this tube, a very low density gas is present, okay, and that gas emits different colorful lights to us. Sometimes we see blue light, sometimes red light, sometimes yellow, different types of lights. So let's say this is two electrodes. This is my electrodes. This is my electrodes. Two electrodes, one is positive, one is negative, connected with voltage terminal. These two electrodes is connected with voltage terminal with positive and negative. Now what will happen? Positive, if positive and negative is there, then what will happen? Obviously the ionization will take place. So after ionization, current will flow and it will emit after see, positive and negative is there, then what will happen? Ionization. So after ionization, what will happen? After ionization, current will flow. After ionization, current will flow and it will emit red color. Means if hydrogen gas is present inside that tube, then it will emit a red color. And if different colors it will emit. And if helium gas is present inside this tube, it will emit yellow color. If neon gas, it will emit orange color. Okay, let me write. If hydrogen gas is present, then it will emit what? Fast. Hydrogen gas, then
Red color.
Red color, ma'am.
yes. hydrogen gas, then red color. Okay, and if helium, the gas is present inside that inside this tube. Okay, and after ionization, means after the positive and negative thing is flowing, after ionization it will emit, the current will flow, and according to the gas it will emit us the color. And what will happen if there is helium gas is present? It will emit what? Helium gas, neon gas, carbon
Neon
dioxide.
was orange, I think, right?
Which one?
Ma'am, neon was orange, right?
Yes, yes, yes. And mercury gas. So helium is what? Yellow color. Yellow. And neon is what, Anam? Orange, na?
Orange, yeah.
Yes. And what is carbon dioxide?
Carbon dioxide,
White. And what is mercury? It's blue.
okay.
So different types of gas. This after ionization, different types of gas will present as the different colors. Hydrogen gas red, helium yellow, neon orange. Okay, like this. Now let's talk about the fifth. It's 55 now. 5 more minutes. Now let's talk about the fifth state of matter. There are total 3 states of matter, as we already know, Razi. The solid one, the liquid one, and the gaseous one. Okay. And what's the fourth state of matter?
Plasma.
And what's the fifth?
Bose-Einstein something.
Bose-Einstein condensate. Okay.
Okay, ma'am.
Fifth state of matter was Bose-Einstein condensate. Condensate. Okay, let me. Just a minute. Do you guys want me to teach this fifth state of matter or this part?
Could you teach it, please?
Okay, but it's only 5 more minutes.
Yeah, but still.
Okay, so in 1924, in 2024, Indian scientist was there, S.N. Bose. This, he is S.N. Bose, Indian scientist. Okay,
Okay, ma'am.
Indian scientist. So he wrote a letter to Albert Einstein. We all know
Yes, ma'am.
Einstein. Hai na? So S.N. Bose wrote a letter to Albert Einstein, and inside that letter, there was a research of statistics, and Albert Einstein work on that research, and later he found the idea. Okay, there's also a fifth state of matter, and Einstein named this fifth state of matter as Bose-Einstein condensate. He wrote a letter, and there was a what? Research of statistics. Research of statistics means when a gas of boson at low density is cooled to temperature, what will happen? A very cool to temperature like minus 273.15 degrees Celsius, then what will happen? The boson will lose their identity and it will behave like a single superatom. See, if this is my boson, because S.N. Bose, so boson, okay. When a gas of boson at low density, at a very low density, is cooled to temperature, cooled around minus 273.15 degrees Celsius. So what will happen? This boson will lose their identity and it will behave like a single superatom. It will what? It will lose their identity. Because see, if we are cooling boson at a very high degree, because zero is only the very high, so minus 273. So obviously boson will lose their identity and it will become what? A single superatom. A single superatom. And what is boson? Okay, let me complete this topic. What is boson? The number of proton plus number of neutron plus number of electron. If we will sum this proton, neutron, and electron, it should come even number like 2, 4, 6, whatever. Then that atom is called boson. And if it is odd, then it is called like fermion. What is boson? Adding this proton, neutron, and electron, we should get a even number. If we are getting even number, then we can say that it is a boson. Okay. And what is boson? If we are cooling, Aram, tell me what is boson. Explain this. Come on, fast. Aram, only 1 more minute left. Come on.
Well, it's what was I couldn't really understand it.
Okay, Razi.
Yes, ma'am. Ma'am, if boson at low density is cooled minus 273.15 degrees Celsius, it will lose its identity and it will become single super atom.
Yes.
And then, ma'am, I'm a little bit confused after that.
And see, what is boson? Like if you are adding the proton, neutron, and electron, it should come an even number. And if it's coming even number, then we can say that it's a boson. And if it's coming odd number, then we can say it's a fermion gas. Okay, Arham, understood. At low density, we are cooling it. So if minus 273 degree is there, so obviously boson will lose their identity and it will become a single super atom. Okay?
Till that I understood.
Huh?
Till that I understood.
So till that, so this part you didn't get, this one. Adding these three, we should get an even number. Then only we can say that, okay, it's a boson gas. Otherwise, no. Okay. Now it's 6 o'clock. Only some parts remaining. I'll teach in the next class. So you got it right. Heating this beaker, it will convert into what? Solid to liquid. If it will heat more, then it starts boiling. If more, then what will happen? Atoms become ionized, means there will be a positive and negative thing. And if there is a mixture of positive and negative, then also then obviously there's a ionized gas. है ना? And ionized is called plasma. And here the same thing is happening. If you are heating electron, means if you are giving more energy to electron, it's what happening? Chalo, fast. What's happening? If you are heating,
Electron will leave the atom and it will become free atom.
electron will leave, if we'll give the sufficient amount of energy, then electron will leave the atom and it will become a free electron. Like here, this is my star, and star temperature is very high, so sufficient energy is available to make electron out from the nucleus. This is also a part of ionization. Okay, the two thing is for ionization, one is star and another one is cloud. This is the application of plasma. Okay, any doubt? Anybody understood everything? Razi?
Yes, ma'am.
Understood. It was easy. Class
Ma'am, it was very easy.
it was very easy, Aram. Okay, it was very easy. Chalo. And this part also, right?
Yes, the Bose-Einstein condensate.
This one, the fully ionized is what? The electron ion is greater than the electron neutral. Partially means neutral.
Yes, ma'am.
Okay. Chalo. It's 6 o'clock. Thank you.
Bye, ma'am. Thank you, ma'am.